Bismillahirrahmanirrahim. Assalamualaikum everyone. Myself Dr. Mimuna Azhar, physiotherapist, and today I'm going to deliver a lecture on the subject of medical physics, and the topic we started in the last lecture was sound waves. We have studied the characteristics and the particular features which are produced from the sound waves. I'm just going to give a brief review about the last lecture, and then we are going to proceed towards the basic characteristics and descriptions of the sound wave. So we studied last time that the sound waves are mechanical waves. They require a medium to travel and they are produced through vibrations. These are the longitudinal waves. They travel parallel to the sources. To and fro motion is produced in that, and there are areas of compression and rarefaction present in the sound waves. So now moving towards the description of the sound waves, it is really important and necessary to identify that there are some points which can explain sound waves very easily. So number one is frequency. What can be frequency? What is the definition of frequency and how we can define frequency? Frequency is a number of cycles in 1 second. For example, a wave is traveling. When a wave is traveling, the number of cycles which are produced in 1 second, that would be known as its frequency. And the formula for frequency is V is equal to F lambda. V is equal to F lambda. Now the second characteristics or description which can explain it is wavelength. Distance traveled in one wave. That would be known as its wavelength. Here I am going to draw the waves and where I will describe the wavelength and the frequency and different terms which are produced in that. So for example, this is the time t and the number of waves produced in 1 second. For example, this is the duration of 1 second. In this 1 second duration, one wave, two waves. Two waves are produced, so the frequency of this waveform would be 2 and it would be denoted as V is equal to F lambda. It is a formula for that. Now wavelength. What is a wavelength? Distance traveled in one wave. So this is one wave and the distance traveled here till here, it would be known as its wavelength. Then time. Time taken to produce one wave. For example, this was the time t in which two waves were produced and that was related to 1 second. Now if we say that how much time it will take to produce one wave. So the time it will take to produce one wave would be till this region. And the formula for time is F is equal to 1 over t. Sorry, my marker is not working so well, but I'm just telling you, and you guys can identify what I'm writing. F is equal to 1 over t. So what we can do is V is equal to lambda over t. This can be the formula which can replace it. Then velocity. Distance traveled by one wave in 1 second. Now the distance traveled by one wave. So this is the distance in 1 second. In 1 second, how much distance a wave travels? In frequency, we just measured that how many waves were present in 1 second. But in velocity, we have seen that how much distance it covered in one wave in 1 second. One wave, 1 second, that would be known as its velocity. And the last thing is about amplitude. Amplitude is the maximum displacement of particles of the medium from their original undisturbed position. So this was all about today's lecture. If you guys have any query or any questions regarding that, you can ask me directly and you can also comment in the comment section. And the assignment for you today is not to write summary. You have to write the definition of amplitude. And this is all about today. Thank you so much.